Sup, MJ? I just put in my stupid Invisalign so my teeth sound all weird. What are you gonna do? Also, the bell's gonna ring in 2 minutes. C'est la vie. Okay, area of a triangle. So, I'm not gonna do, well, let's do rectangles really quick. There is a video on rectangles, and I go over it again, the parallelograms, but let's just build one really quick. So, there is a 4x3 rectangle, okay? If I measure those sides, it's gonna say 4 on the bottom and 3 going up. You wanna call it one length and one width, or you wanna call it base and height. It doesn't matter. 2 dimensions, it's a 2-dimensional shape, okay? Multiply them, 4 times 3, you get 12 units squared. I can also count the squares. Again, that only works when the squares are full squares. As soon as you get into decimals and fractions, stuff like that, it's annoying. So it's good to know the formula, right? So let's write the formula on there because it's going to come into use later. So area of rectangles / squares is, generally they call it length times width. Okay, but one dimension times another. If you want to think about it as base times height, that's probably more useful because a lot of our other formulas, including parallelograms, are going to build off of that, okay? So this is length or base, and this can be width or height, whatever you want to call it, 2 dimensions. That's why it's units squared, right? So 12 units squared. 2 dimensions gets the little 2. Okay, on to triangles. So triangles are obviously not rectangles. They are still a polygon. A polygon just means a closed, straight-sided shape. So a rectangle is a polygon because it's closed and straight-sided, and a rectangle happens to have 4 sides, whereas a triangle obviously has 3 sides, 3 angles. So I'm going to make a right triangle first, and it's called a right triangle because it's got a right angle here, or the right angle could be anywhere, but mine happens to be there. And let's put the side lengths on there as well, because it's going to come in handy also. So I have 3 side lengths, triangle, 3, right? And one of them's 5, one of them's 4, and one of them's 6.4, okay? Any of those can be the dimensions I use. I could use 6.4 as my base, but then I'd have to measure coming out at a 90 degree off of the base up to this point F here perfectly, and I don't have that measurement, so I would have to create it and have to be super precise. Instead, it makes a lot more sense to use the measurements that I have available, okay? And area of a triangle, is, wow, even for me that's pretty terrible. Area of a triangle is base times height, okay? I'm gonna put that maybe in brackets, although you can kind of do what you want. And I like to put it over a 2.
Could the following 3 students
Quite an announcement here.
report to the office for dismissal? Katie Haverstock,
Katie Haverstock.
Homan Wong,
I'm not sure who that
and
is.
Horace Wong.
Or that one. Okay, some people like to rate it like that.
Homan Wong and Horace Wong.
There we go. Some people like to multiply it by a half. You don't see it a lot, usually these other 2, okay? Anyways, the whole point is it's base times height, same as rectangles, and then you divide it by 2. Okay, so I'll show you why in a second. But here we go, we got these 3 dimensions that are potentially can be used. Makes sense in this case to use 4 as my base and 5 as my height, okay? Because I know them. If I use 6.4 as my base, like I said, I need to use this I need to precisely measure a height that goes from the base to point F at a 90 degree angle, and I just don't have that information, and you guys know my artistic inability. I'm not gonna be able to create that, okay? So this number is not helpful for area in this case. Perimeter, I need it. Could I use it for area? Yes, but in this triangle situation, I would choose to avoid it because it's not going to help me like 4 and 5 are gonna do. 5 could be the base, and 4 could be the height, if you can imagine it just shifted, but that's what I got. Okay, so just going through the formula here, so I'm gonna go, 5, well, let's keep it 4 times 5, doesn't matter which order it goes in, divide by 2, so that would be 20, divided by 2, which is 10 units squared. Okay, so that is true. If I go back to my area measurement tool, which is over here somewhere, there it is, and I click on this shape, you will see it is in fact 10. So I did it correctly. Now, more importantly is why. Why does that work, MJ? Well, let's build a new one here. Let's go back to the top rectangle that I made that was 12 units. So I said it's 12 units squared on this rectangle, okay? So we're gonna build a triangle inside of this rectangle, okay? Just for fun. I'll make a different color. So I'm gonna build a right angle triangle inside this rectangle. And if I click it, I can change its color. Let's make it red so it stands out a bit. Okay, so you can see that triangle is inside the rectangle. Well, guess what the area of that triangle is? It is half of the rectangle. So the rectangle was 12. The area of this triangle is 6. How do I know that? Well, let's try the formula again. 1, 2, 3, 4 could be my base. So base is 4 times the height, 1, 2, 3, 3. And like I said, you have to divide it by 2. So 4 times 3 is 12. Divided by 2 is 6 units squared, okay? How do I know that that works? If you trust me that the formula works, that's great. I promise I'm not lying. But it also makes sense if you look at the actual shape. Why do we divide by 2? Because dividing things by 2 is cutting them in half. You get a pizza and you divide it into 2 parts. You have half a pizza, right? So dividing by 2 of this rectangle, because remember, the rectangle is 4 by 3. The triangle is not the full rectangle. Well, how much of the rectangle is it? It's half. I can see that, right? It's exactly half. I cut it right down the middle, okay? So that's why we divide by 2 with triangles, okay? That's the proof. That's the formula. Now you know why it works, okay? Now, sometimes you might get some crazy looking triangles, right? Maybe let's make one that looks pretty wild here. Let's make it look like this. Okay? Crazy looking triangle. It's hard to see, how I would cut this to make a rectangle. I don't really know if I added to the side. I'm not really sure how to make a rectangle. Like if I look back to this bottom one, I can imagine it being a rectangle, right? I just add on this part right here. Oh, okay, right? It's a 4 by 5 rectangle, 20, cut in half, that's why it's 10. With this one, I can't see how I would slice and dice it. And that's really where the formula is gonna come in handy, okay? Because I'm gonna use 2 as my base. So base times height divided by 2. So 2 times something divided by 2. And what's my height? Well, in this case, I don't really know. So I gotta go to the top point, just kind of like we did with the parallelogram video. If you didn't watch that, go check it out. That's gonna be my height, okay? It's not gonna go like from J to H on a crazy diagonal line. It has to be off the base, even if you have to extend the base out, and then up the height all the way to that top point, okay? So that's 1, 2, 3, 4, okay? So it'd be 2 times 4 divided by 2, that's 8 divided by 2, that's 4 units squared, okay? And I can kind of see, like, if you add all those little bits of squares up together, it makes sense to be 4. But just to prove I'm not lying, let's bring that area measurement tool back, and let's just make sure that it is, in fact, 4. There it is, okay? Common mistakes kids make are they forget to divide by 2, okay? And if you're using grid paper, you should be able to, like, kind of count, right? Like, if I had done 4 by 2 and said 8, and then just forgot to divide by 2, I should look at this triangle and be like, that doesn't look like 8. And then I should hopefully recognize my mistake. The other mistake kids make with weird triangles like this one is they don't see 2 as the base. They're like, oh, it's 3, 4. They use 5 as the base. No, the base is always 1 side length. It never has any extra added onto it or anything weird like that. The height sometimes is outside the shape, but that's still how tall it is. If I was to go again from the base here up, it would still have to go up 4 to get to this highest point, even if it's a real slanty boy like that, okay? The right triangles are always the easiest to see the height and the base. So if, for example, on my test, I guarantee you I'm going to ask you to make a triangle of a certain dimension, build a right triangle instead. It's easier to keep track of, okay? Yeah, hopefully that's helpful. Triangles, booyakasha.